Session 2.4 Solutions and Applications of White Triangles. Significant digits. A significant digit is a digit obtained by actual measurement. Rules for significant digits, or you could call significant figures. First one, all non-zero numbers are significant. So if we have a 33.2, we're gonna say we do have a three significant figures. Okay, three significant figures because there's no zeros in here. Zeros between non-zero digits are significant. So if I have a 2051, since the zeros is in between two numbers, so we would say we do have a 4-digit significant figures. Number 3, leading zeros are not significant. So if we have a 0.54, since the zero is in front of this numbers, so we only can say this is a 2 significant digit. And if we have a 0.0032, since all these 0 are leading 0, so same idea, we only have a 2 significant digits. Changing zeros to the right of the decimal are significant. When you have the 0 after the decimal points, we consider these 2 zeros are significant. So in this example, we do have a 4 significant figures. Okay, 1, 2, 3, 4. Number 5, changing zeros in a whole number with the decimal chosen are significant. Look at this example. When we have a 540, if I put the decimal after the whole number, then we're gonna consider we do have a 3 significant figures in this example. Okay, but if I didn't put like the decimal point after the whole number, that would be using the rules number 6. Changing zeros in a whole number with no decimals so are not significant. So I use the same example. If I only show you guys 540 without the decimal point here, then we consider we only have 2 significant figures, okay, 5 and 4. Because the 0, we don't count it. Okay, watch out the number 5 and number 6 in here. Okay, example, how many significant figures? I want you guys try, just write it down, how many significant figures for each number. Okay, check your work. The first one, 408. Since the 0 in between these two numbers, so we do have a 3 significant figures. Second one, 21.5. So all numbers are non-zero, so we do have a 3 significant figures. And then 18.00, the 0 is after the decimal point, so we do have a 4 significant figures. Same idea for 6.700, so we do have a 4 significant figures. And then 0.0025, we do have the 0 for the leading 0, right? So we only have a 2 significant figures. And then 0.09810, okay, we do have the leading 0, so we don't count these 2. And then the 0 is after the decimal point, so we do have a 4 significant figures. And then last one, 7,300. Since I don't have the decimal point here, so we only have a 2 significant figures. Okay, but if I add 7,300 and then the decimal point, then that will be 4 significant figures. Okay, to determine the number of significant digits for answers in application of angle measure, use the following table. So when we have the degree, 62 degree and 36 degree, so both of them, they are non-zero numbers. So we do have two significant digits. And then this one, 52 degree, 30 minute. Okay, we don't have the decimal point here, so we only have three significant digits. This one, we do have the decimal points and the zeros is in between these two numbers, so we do have three significant digits. Same idea here, we do have 4 and 4 significant digits. Okay, this one, 10 degree, 15 minutes, and 20 seconds. So we don't have the decimal point here. We don't count this zero. So we have 1, 2, 3, 4, 5. Okay, 5 significant digits. Solving triangles. To solve AA triangle means to find the measure of all the angles and the size of the triangle. So we do have the white triangle here. Okay, solve the AA triangle means you want to find the angle A, angle B, angle C, and the side ABC. And when solving triangles, a label sketch is an important thing. So you could see when I have the angle A, we use the capital letter of the angle, and then we use lowercase letter for the side. And the side is always opposite to the angle. If this is A, this is going to be A. Same idea, C will be the 90 degree. The opposite side, which is going to be your hypotenuse, will be using the lowercase letter C. Okay, B also, capital letter B will present this angle. Lowercase letter b will be opposite to the angle B here. And then in a white triangle, letter C is reserved for the hypotenuse. Example 1. Solving a white triangle given an angle and a side. Solve the white triangle ABC. And then angle A will be 34 degree, 30 minute. And then the C, the side of the C will be 12.7 inch. Okay, so we could use the side A. Side A will be opposite over hypotenuse. And then I'm gonna multiply 12.7 for both sides. Use your calculator. You're gonna get A equal to 7.19 inch. Remember how to use your calculator with this angle? Let me show it to you guys. Okay, when the given angle is 34 degree, 30 minutes, and you want to convert it to the decimal space and put it to your calculator, what are you gonna do? 34 degree, 30 minutes, that will be equal to 30 degree plus 30 degree divided by 60. And then use your calculator. You should get 34.5. Okay, so try it with your calculator. 12.7 side 34.5. You're gonna get 7.19 inch. Okay, we covered this part on the session 1.1. If you don't remember, you could review the video lecture from the session 1.1. Okay, so we find the length of the side A here. Now we want to find the B. Okay, so this time we're gonna do cosine. Cosine A equal to adjacent over hypotenuse. Okay, plug it in. Do the same thing, use your calculator. You should get 10.5 inch. Okay, so you can find the B. Now, we need to find the angle B. Okay, we know the angle A and angle C already. So we could do 90 minus angle A. Plug it in. Now you have 90 degree minus 34 degree, 30 minutes. Okay, let me show you guys how you get this answer. Okay, so you have a 90 degree minus 34 degree, 30 minutes. So we don't have enough. We're gonna borrow 1 degree from here. So we have a 89 degree. 1 degree will be equal to 16 minutes minus 34 degree and 30 minutes. So you subtract it. That will be the minute. And then 89 minus 34. So you will have a 55 degree, 30 minutes. Okay? Okay, example 1, we could have found the measure of angle B first and then use the trigonometric function values of B to find the unknown size. Another way to solve this white triangle, we could just find out the angle B first. And then you're gonna use the angle B to figure out your A and B here. A white triangle can usually be solved in several ways, each producing the correct answer. To maintain accuracy, always use given information as much as possible and avoid wandering off in intermediate steps. After you find out the length of the side A here, you could use the Pythagorean theorem to find out the B. Okay, but I would recommend you guys try to use the given information to solve the white triangle. Okay, example 2. I want you guys try to solve this white triangle ABC. So figure out what is your side B, what is your angle A, what is your angle B. Okay, let's check your work. I will try to find the angle A first. So I'll be using the side A. Side will be opposite over hypotenuse. Plug it in. So angle A will be equal to the inverse of the side, this guy. Use your calculator. You should get 33.32, or you could convert it to the degree and the minute. For the exam, you don't have to convert it to the degree and the minute. I will accept this answer already, okay? After you find the angle A, now you want to find the angle B. You could subtract 33 degree, 19 minute, or you could use 90 degree minus 33.32. Okay, now you could use the Pythagorean theorem. Okay, a squared plus b squared equal to c squared. Plug it in. You should get 44.77 centimeters. Angles of elevation or depression. So X is gonna be the horizontal. And then when we talk about the angle of elevation, means you're gonna look it up. Okay, you're gonna look above the X in here. And then when you have the angle of depressions, you're talking from the point X to the point Y, so below the X. Okay, you could think about it, you're gonna look it down like this. Be careful when interpreting the angle of depression. Both the angle of elevation and the angle of depression are measured between the line of the side and the horizontal line. Okay, keep in mind, both of the angle, you do have the horizontal side here. Solving an applied trigonometry problem. Draw a sketch and label it with the given information, and label the quantity to be found with a variable. And then use the sketch to write an equation relating the given quantities to the variable. Then solve your equation and check your answer to see if it makes sense. Okay, let's try. At a point A, 123 feet from the base of a flagpole, the angle of elevation to the top of the flagpole is 26 degrees 40 minutes. Find the height of the flagpole here. So angle of elevation. So you're going to be looking up, right? Look above the X. So this is going to be horizontal line and it create a white triangle. So we do have the degree. We know about the adjacent and we want to find the opposite. So let's use the tangent. Tangent is going to be opposite over adjacent. Okay, then use your calculator. Remember how to convert it to the decimals? You could do 26 plus 40 divided by 60. You should get 61.8 feet. Okay, answer the questions. The height of the flagpole is going to be 61.8 feet. Example 4. Finding an angle of depressions. From the top of a 210 feet cliff, David observed a night house that is 430 feet offshore. Find angle of depression from the top to the cliff to the base of the night house. Okay, they give you the picture already. So it create a white triangle here. And then you know this is a 430 feet. And then the height of the cliff is going to be 210. And we want to find this angle. Remember on the session 1.2, we talked about the corresponding angle, alternate interior angle. This is just looks like the letter Z, okay? The letter Z here, right? You flip it, and you know these two lines is going to be parallels. So you need to find the angle B here, ABC, the angle ABC. That will be equal to your angle of depression. So if I want to find the angle ABC, so that will be using the tangent, right? Tangent opposite over adjacent. Use your calculator. You should get 26 degrees. And that will be your angle of depression. That's it.